Welcome to the presentation of Dark Control, AI and Humanity's End, a book by Michael J. McCarran, myself, who is speaking. In this presentation, we're going to go over the first part of this book. There are 8 parts of the book. The first part is AI and cybersecurity. Now, cybersecurity and AI is a bit different because in normal cybersecurity, when we're dealing with computers that do not have any kind of machine learning or adaptive feedback loops to them, most cybersecurity is dealing with overt malicious acts, planned cyber attacks. Somebody is sitting down deciding to do something. But with AI, you can also have malicious attacks where you can use the tools of AI to expedite your attacks. But you can also have attacks that just emerge out of the technology itself. And this is like one of the critical things to understand about AI, that some AI attacks are malicious with intent and some are emergent, that are byproducts of the technology itself. One of the problems with understanding AI, and this is pretty well understood these days, but that is the black box problem. Again, with cybersecurity and dealing with typical normative cybersecurity as we've understood it up to this point, we're dealing with computer systems where you can look at the code, you can understand how the algorithms function, you can understand why the algorithms produce the outputs that they produce or do what they do. But with AI, you can't understand the full chain. You can only understand some inputs, you can understand some outputs, but the large language model or any model-based AI system is going to have a black box where you can't understand how it specifically is coming to the conclusions it's coming to, which makes vulnerabilities hard to detect and malicious use hard to monitor. And you can't really predict what it might come out of this. Now, we talk about machine learning. There are several kinds of machine learning. We're just going to go over some of the basic ones. Supervised learning is when you, one of the biggest differences between machine learning is whether you put a label on something. You can have data, but you can put an annotation on that data that this data represents a big tree. Or you can just have the data where the data points are pixel references which depict a tree. This is called supervised learning, when you put these labels on things. Unsupervised learning is when the computer figures things out through not having these labels being put on things. It can find patterns, and it can tell you what the nearest neighbor, k-nearest neighbor algorithm should be, and stuff like that. Another important part, which we are going to be dealing with extensively in this work, is reinforcement learning, which began around 1989, which learns through trial and error from rewards. And we're going to go over this pretty well in depth, not too deeply in depth that you have to have a master's degree in computer science to understand it, but enough so that you can understand why things are happening the way they're happening in your interactions with artificial intelligence. When we're talking about AI today, the biggest thing that the consumer, that the average person, the citizen is going to be dealing with is language models. Now, we say large language models. There are also small language models. Models that are large tend to deal with a large quantity of knowledge, whereas smaller models deal with specific tasks, and they have been shown to be very successful at using these small language models. Large language models are more a generalist, trying to get a computer to be able to do anything that any human can do anywhere. One of the things that when we're talking about large language models is that these are statistical pattern inference devices. They're not. They're based on probability. They are not deterministic. And this is one of the chief differences between this and like computers before. Now we're dealing with systems that have probabilities of performing a function a certain way again and again, not deterministic certainty that it will always produce the same output from the inputs you put into the system. And this gives us the point that cybersecurity for computers is, very deterministic. Like I've been saying, it's very, you can tell what's going to come out of it by what's going to go in it. But cybersecurity for large language models is probabilistic. It's very dynamic. It has emergence to it, and we're going to go over emergence in more detail later. But it can be unpredictable, and threats can swarm up, and all kinds of different unexpected things can come out of cybersecurity for AI. Now, these large language models are comprised of neural networks, just like your brain is a large structure of neurons, which are networked together, and the what you would call like the materials that the nodes in the network, the neurons, are made of is kind of irrelevant. For us, we're talking about biological brains. In this instance, we're talking about virtual representations of brains in neural networks. And these representations of these neurons go into these large language models through something that's known as like their weights, which is kind of like, I kind of think of the weights as like a holographic representation of the large language model myself. But these weights can represent text, it can represent images, it can be code, it can be, all kinds of different things now. A weight lets you know how significant a node or a neuron is. The larger the weight, the more significant. How you develop these large language models is a process. And it starts out with data collection, then you go through pre-training and fine-tuning, then you integrate it into an application or a system, like a corporate infrastructure or something like that if you're using it for some kind of analytics within your corporation. Post-deployment monitoring is when you look for, odd behaviors coming out of the system, because in testing does not predict actual real-world deployment. One of the biggest points about all of this is data collection, is that the data that goes into these systems is going to affect how the systems perform. So if you have biased data going into the system is going to produce biased results. If you have not enough knowledge in the data, then it's not going to be able to perform tasks that you want it to perform, because it doesn't have the training data to perform those functions. Now, one of the biggest problems with large language models is the feedback trap. It's a closed loop, and we're seeing more and more evidence of this coming into fruition in the real world through AI's influence on human culture. What happens is the data that you train on, that the large language model is based on, is also being shaped by the large language model. And this creates sort of a closed loop where you're training on the data but also producing that which you train on. So if you can imagine, like a genetic equivalent would be like being inbred all the time. And you can see how limiting that would be. So errors don't correct, they just compound. Like I said, we're starting to see a graying out of culture and society because of this effect. Now, one of the biggest keys to understanding large language models is the understanding of alignment. Alignment means that ensuring the AI's goals align with human values and safety, that they aren't being built to do destructive things to humanity. One of the ways you control this is by using what the industry calls guardrails, which are safety features that prevent harmful behaviors being conducted to the model. How these, if you're familiar with large language models and interacting with large language models, you know the importance of the prompt, that the data you put in, the text that you give it, will form what you get out of it. Now, one of the ways that people are doing to break these large language models, which is known as jailbreaking, is to use prompts. The language you put into the model, because it's a language model, affects how it functions, so you can put language into the model to break the model or use it for illegal or malicious purposes, which you shouldn't normally be able to do, like creating a weapon or something like that. But also, one understanding is just because you have an aligned model doesn't mean it's not going to end up being used for coercive purposes or illegal purposes. Now, as we were saying, the way you get a model to behave badly is prompt injection engineering. Now, this is exploiting large language model vulnerabilities by manipulating outputs via crafted prompts. There's two ways to do this, a direct way and an indirect way. A direct way is when you text directly into the interface a prompt that can jailbreak it. An indirect way is when you provide an uploaded file which has instructions within that file to break it. So there are many different ways that you can use to, break a large language model, then use that as a tool to conduct massive malicious intent, not just locally, but across the world. One of the understandings about, large language models is they're based on transformers. Now, transformers came into use around 2018 or 19. Back then I had started noticing like Hugging Face was becoming popular, so I started playing with some of the not the large language models, but the various language models at Hugging Face, and you could build, basic chatbots and entertain yourself with those chatbots. And one of the things you started noticing back in those days is like how Hugging Face, some of the models would allow you to put different personas to the responses you got out of the language models. But the way the great advance was the use of attention and transformer architecture. Now, what this is based on is breaking down the prompts, like the text you put into those prompts breaks it down into different tokens, or breaks all the words down and has mathematical representations. Then what basically happens is attention will go through there and give different weights to the different words, and then you get the output, which gives different weights for those different combinations of words. Another key concept in understanding in large language models is that of backpropagation. A supervised learning algorithm used to train neural networks. Backpropagation involves adjusting the weights to minimize the loss between predicted output and actual output. Now, this sounds like it's really complicated, but you can basically think of it as like your spell checker on when you're sending an email is basically, it's going through there and it's constantly updating your mistakes. Well, this is kind of similar, except it's constantly updating the weights, which we understand to be kind of like a representation of how everything fits together within the model. And the way it does that is through using a loss function. And I don't want to bog you down into too many technical details, but you can always read more in one of my previous works, which is in bibliography regarding machine learning and video game design, if you want to get more into depth on how machine learning functions. But another thing to understand about large language models is that of reasoning. Now, when you type into these prompts, and depending on which large language model you're using, sometimes they show you how the system itself is breaking apart the problems you gave it. This one of the things it's doing is it's actually doing which is very similar to like a Navy SEAL self-talk methodology. I don't know if you know this about special forces or special operations people. They will, in combat, in an operation, they will talk themselves through what they're doing. And this is also seen in large language models. This self-talk in machine terms is known as chain of thought. It could be given like the prompt, calculate the total price if you buy 5 apples at 60 cents each and 3 oranges at 75 cents each. Then it's going to go through there. It's going to break the task down, the problem down into different component parts and complete the operation for those component parts. There is another function of this reasoning. It's called tree of thought, where it kind of explores multiple lines of reasoning to find the best solution. Now, tree of thought is thought to be more secure than chain of thought, which can be exploited by malicious actors. But one of the problems is, even with these updates, older systems are still going to have the old technology in them, which can be exploited by malicious actors. And that brings us to, security breaches that can occur in multiple different ways using AI. And the way we look at, how to categorize AI and cybersecurity is to generate a threat matrix. This is well known within cybersecurity circles, to generate these threat matrices. In this case, we have things like data breaches, network intrusion, and automated phishing. The thing about these things is that it can be very adaptive and evasive, and it can even use generative AI to generate, photographs, even voice recordings, or even video recordings to fake staff into doing things that they shouldn't be doing for their organization. There's a large and growing attack surface for large language models. As you can see in this slide, we don't need to really go through them. If you want to read in the chapters in each part of this book, you can go into depth on these things and find references, and you can go further into how this is done and how to mitigate these problems and how to develop countermeasures to these problems. But now we're used to, firewalls protecting us. If we want to protect our cybersecurity, when we think of cybersecurity, we think of a firewall that nobody can penetrate my network, so everything is secure. But we're not dealing with that kind of cybersecurity here anymore. There isn't a firewall for large language models, for agentic AI. So with this problem that there's no, surefire way, there's no hard firewall to prevent this, you would think that cybersecurity would be a major priority of the government of the United States. But since the Trump administration has taken over, we've seen dismissed top leaders of CISA, which is, the cybersecurity agency of the United States. They have a huge staffing problem now because they fired too many people when the administration came in. They slashed the budgets and they cut intelligence oversight, they gutted the workforce, and now there's a huge brain drain, and now they're scrambling to bring people into their staff again, realizing that they cut too far and too deep. Now, another problem with this is that you have unqualified people leading such organizations as CISA. For instance, we could quote or cite the recent incident where the acting head of CISA was given a lie detector test because they requested access to compartmentalized information that they don't normally need, so they had to pass through, which was standard procedure, a lie detector test to access that information, even though they didn't really have a need to know of that information, and they failed that lie detector test. But these are the people that are in charge of CISA currently as acting leaders, not confirmed leaders. So, who is securing AI then, if the government has passed the ball on to not doing anything for whatever reasons they passed the ball on to? Well, private organizations are doing something about it. There's OWASP that has standard procedures that people can follow for large language models. NIST has also come up with some things, and the well-known cybersecurity organization known as Meter has come up with their own, risk management framework. But if we look at the OWASP top 10 for large language model threats, we get things like prompt injection, which we have gone over, insecure output handling, and this is a case where XAI came into some problems, where they were outputting photographs of real people naked, and that's an example of insecure output handling. You can get training data poisoning. You can poison the data that it's trained on to do malicious things. You can even use it to bombard the model to prevent it from working for anybody, and that's known as model denial of service, which we're used to talking about in distributed denial of service, or just a straight up denial of service. And you can also have data leakage. There's just many ways that this can be done. One of the most interesting things about a threat is the excessive agency, that granting LLMs overly broad decision-making powers. That's either through people just taking themselves out of the loop or not having themselves in the loop at all. And then the AIs can just do whatever, which can be compounded by hallucinations, because the LLMs can just generate fantastical solutions just for the sake of saying that they generated a solution, which is a very strange thing to be in. And that is a broad overview of part 1 of DarkControl. And like I always say, be a cyber survivalist. You are your best defense. To read more about this, you can go to follow this QR code and read to your heart's delight.